Hi everyone, welcome to the end of chapter 4. This is section 4.7. It is titled Coordinate Geometry of Triangles. What we're going to do is we're going to put triangles in a coordinate plane and label the vertices, A, B, and C, but also with that ordered pair and be able to explore a lot of their properties. So let's get started right away. I've drawn triangle ABC on this coordinate plane and labeled the 3 points A, B, and C. What I want to do now is I want to find the slopes of all three sides and the lengths of all three sides so that I will be able to classify this triangle. Is it acute? Is it right? Is it obtuse? Is it scalene? Is it isosceles? Is it equilateral? I need to find that out, so I need two things. I need the formula for finding slope and I need the distance formula. I'm going to start with side AB, which is right here. I'm going to start with the slope, and I have two ways I can do that. I can count squares, which will give me the slope just fine, or I can go y minus y over x minus x, which will also give me the slope. So if I count squares, I go up 6 and to the left 8. So that would be 6 over negative 8, or negative 3/4. I took the time to do a mental check looking at the ordered pairs to see if I would get the same numbers going y minus y over x minus x, and I did. So I feel pretty confident about that. So now I'm going to apply the distance formula. Remember, the distance formula is the difference between my x's squared plus the difference between my y's squared and then the square root of that. It's based on the Pythagorean theorem. So hopefully you remember that. Let's apply that to these 2 points. Okay, so let's walk through distance formula with these 2 points. It's going to be the square root of the difference between my x's, negative 7 and 1. So negative 7 minus 1 would be negative 8. I don't care about the negative because I'm going to square that. So that's going to be 8 squared plus the difference between my y's. My y is 1 and my other y is negative 5. So the difference between negative 5 and 1, negative 5 minus 1 would be 6. So that is 6 squared. So 8 squared is 64. 6 squared is 36. And that's 100. And the square root of 100 is 10. So that one has an actual natural number for its length. Okay, I want to go through the same process with my side BC. I want to find its slope and then its distance formula. By the way, it doesn't matter what order. I could find all 3 slopes and then all 3 distance formulas. I just decided to do one side at a time. So if I find the slope, my change in my y from negative 5 up to 3 is 8, positive 8, and then from 1 to 7 is positive 6. So it's positive 8 over 6, or my slope is 4 over 3. Now I will apply the distance formula. The difference between my x's, this one is 1, this one is 7. So the difference between 1 and 7, 7 minus 1, that's 6. So this is 6 squared plus the difference between my y's, negative 5 and 3. The difference between that is 8. So that is 8 squared. That's 36 plus 64, which is 100. This side has a length of 10 also. So let's look at what we found out already. If I look at these 2 sides, this one has a slope of negative 3 over 4, and this one has a slope of positive 4 over 3. Those slopes are opposite reciprocals. If I multiply negative 3/4 times positive 4 over 3, I get negative 1. Therefore, these 2 are perpendicular. That is a 90-degree angle. So I'm going to mark it 90 degree. Also, AB has a length of 10 and BC has a length of 10. So these 2 have congruent sides. Right away, I have a right triangle and it is isosceles. So theoretically, unless the assignment requires you to find the third side, I've done everything I need to do to classify this triangle. I know this isn't going to be perpendicular or anything as far as finding the slope. I can check to see if it's also 10, but if it was equilateral, this angle would be 60. So I know it's longer than 10 and 10, so I can be finished. This is an isosceles right triangle. Okay, I want to teach you or explain to you about a special thing we can do with triangles, and that's draw a mid-segment. So a mid-segment of a triangle is a segment that is created by connecting to a midpoint of two sides. The midpoint of one side of the triangle connected to the midpoint of another second side to a triangle will give us, that segment will be called a mid-segment. So what I want to do is I want to connect the midpoint of AC and the midpoint of BC and draw its mid-segment. That means I need to find the midpoint. So remember, the mid is in the middle. It's just the average. So the midpoint is the average of the x and the y, the average of the x and the y. So let's find the midpoints and then connect them so that we have our mid-segment. Okay, our midpoint is the average of the x and the average of the y. So the midpoint here is the average between -7 and 7. If I add -7 plus 7, I get 0. And that divided in half is still 0. So I know the x value of my midpoint will be 0. Now I do the same thing between the y's. This y is 1. This y is 3. 1 plus 3 is 4. Half of 4 is 2. So my y coordinate is 2. There is the midpoint of AC. It is 0, 2. Now let's do the same process through BC. Then my x's are 1 and 7. So I'm going to add those together. 1 plus 7 is 8. Divided in half is 4. So I know my x value will be 4. Do the same process with my y's. This y is -5 and that one is 3. Add them. -5 plus 3, -2. Then divide that in half. Half of -2 is -1. So that midpoint should be 4, -1, and there it is. So now I'm going to connect them and then label them C and, not C and D. I'm going to label them D and E. So connect my two mid-segments. This one I'll call D. This one I'll call E, and there's my mid-segment. Now what does a mid-segment do? They're pretty magical, because if it's right in the middle here, this mid-segment will always be parallel with the other side, the side that it's not attached to. So DE and AB will always be parallel. That's cool. The other thing that's really neat about mid-segments is the length of this mid-segment is half of the length of this third side that it's parallel to. So we already said the length of this side was 10, remember? Then I know without checking that DE, the length of DE must be 5. I want to walk through the distance formula between points D and E just to verify this. So my point D is 0, 2, and my point E is 4, -1. So I'm going to walk through the distance formula, the square root of the difference between my x's, which is 4 squared, and the difference between my y's, 2 minus a -1, which is 3 squared. So 16 plus 9 is 25, and the square root of 25 is 5. It works every time. Also, we found earlier that side AB has a slope of -3/4. Guess what the slope of DE is? It's also -3/4. They are parallel. Okay, what I'm going to do now is I'm going to find the midpoint of AB, and I'm going to do my other two mid-segments and find the same characteristics. So the midpoint between A and B negative 7 plus 1. Remember the average, you add them up, divide by 2. Negative 7 plus 1 is negative 6, divided in half is negative 3. And then my y's, 1 plus negative 5 is negative 4. Half of that is negative 2. So this midpoint should be at negative 3, negative 2. There it is. So now if I connect, I'll call this F, and I'll connect it to E, and I will connect it to D, and now I have all 3 mid-segments. DF is parallel to BC, which means it has the same slope, which was negative 4 over 3, positive 4 over 3. So 1, 2, 3, 4, 1, 2, 3. Yep, positive 4 over 3. And it's half of its length, so it should also be 5 because BC was 5. We did not take the time to find the slope or the length of this third side because we didn't have to classify it. But these two slopes should be the same. So this slope is 1 over 1, 2, 3, 4, 5, 6, 7, 1 over 7. This should also be 1 over 7. I go up 2 and over 14. Sure enough, they both have a slope of 1 over 7. Let's go ahead and find the two lengths and compare them just to confirm that FE is 1/2 the length of AC. So let's apply the distance formula. The difference between my x's, which is negative 7 and 7, that's 14. So this is going to be 14 squared plus the difference between my y's, 3 minus 1 is 2, plus 2 squared, or plus, I'll just write 2 squared. So that's 196 plus 4, that's the square root of 200. And 200 is 100 times 2. So the square root of 100 is 10. So this is 10 square root of 2. That is the length of AC. Let's do the same for FE or EF. Let's find the difference between my x's, which is negative 3 and 4. And the difference between negative 3 and 4 is 7. So that's 7 squared. Plus the difference between my y's, which is negative 2 and negative 1, that's just 1. So that's 1 squared, that's 49, that's the square root of 50. And you may look at that and think, wait a minute, 50 isn't half of 200. But let's simplify it, because 50 is 25 times 2, and 25, the square root of 25 is 5. So this becomes 5 square root of 2. And isn't 5 square root of 2 exactly half of 10 square root of 2? It is. So it works for all 3 sides. Those are mid-segments. Mid-segments are pretty cool. Now I want to show you something that you could do with coordinate geometry that is a little bit more complicated. So I've put this triangle on a graph, and I didn't even bother with lines because I'm not using numbers. Instead of numbers, I have given my points letters, variables. So my point A in this triangle is x minus r, comma, y. So my x coordinate is x minus r, my y coordinate is y. Point D is just xy. Point C is x plus r, y, and point B is x, y plus s. Notice this point B is directly above D, so my x's are the same, and then my y's change. And A and C are same horizontally, so my 2 y values are the same for A and C, same variables. Now what I'm going to do is try to prove that triangle ABD is congruent to triangle CBD with no numbers. I'm just going to use variables. So let me walk through how you can do this. It kind of blows your mind. And it gives you an idea too of where we get our formulas from. How are these people able to come up with these creative formulas just involving letters? Because they look at these constant relationships that will work no matter what the numbers are. That's the advantage of using variables instead of numbers. So let's walk through it. If I'm trying to prove that this triangle is congruent to that triangle, notice right off the bat they have a shared side. They have BD. So I'm going to start, because all I have is the figure, I'm going to start that BD is congruent to itself by the reflexive property. Okay, now my next step is what would be easiest to find. And if I look at this, because this line looks like it might be horizontal and this line looks like it might be vertical, these two angles might be right angles. So let me look at the slopes of each one and see if the slopes are perpendicular. So I'll start with the slope of BD. So the coordinates of BD, B is x, y plus s, and D is xy. So the slope is y minus y over x minus x. So I went y plus s minus y over x minus x, and my slope ends up being s over 0. Since it's over 0, this is an undefined slope, so it is vertical. Okay, now let's find the slope of AC, y minus y over x minus x. Y minus y, because those happen to be just y and y in A and C, that's 0 over, and it ends up being over 2r. But it doesn't matter, it has a slope of 0. So my justification for what I found is the slope formula. That's what I used to find my two slopes. And what that means is those two segments are perpendicular because vertical and horizontal lines are perpendicular. All right, so I wrote in what comes next. Because these two lines are perpendicular, then those are right angles. That's what perpendicular means. Perpendicular lines form right angles. So I have angle ADB and angle CDB are right angles just based on the definition of perpendiculars. So now I have BD is congruent and I have these two angles. All I need is another side. Can I show AD is congruent to CD? Let's try that. Let's apply the distance formula that we were using just a minute ago with letters. So I'm going to find AD, the difference between my two x's. So that's x minus r minus x. The difference between those two would be r squared. Even if it's negative r, it doesn't matter. It's still r squared. Plus the difference between my y's, y minus y is 0, plus 0 squared equals the square root of r squared, or r. So the length of AD is r. Let's go through the same process now with CD. The difference between my x's, so this is x plus r, and this is x. X plus r minus x just leaves me r. So that's r squared, plus the difference between my y's, well, y minus y is 0, so plus 0 squared. So again, I'm left with the square root of r squared, which happens to be r. So I've shown using the distance formula that these two are congruent. Therefore, since this equals r and that equals r, now I can say AD equals CD by the transitive property. AD equals r and r equals CD, so AD equals CD by either the transitive property or substitution. If those two segments, their lengths are equal, then I know they are congruent. So now I'm going to say AD is congruent to CD by definition of congruence. And now I can say triangle BDA is congruent to triangle BDC, which is what I'm trying to prove. I can now say that, or I'm sorry, ABD is congruent to CBD. I want to be consistent here. But I can say that they're congruent because I can either say side LL, because they're right triangles. I've shown that they're right triangles, and the two legs are congruent, so I can write LL, or if I want to, I can write side angle side, and it will mean the same thing. And so I've proved it without even a single number. That's what coordinate geometry will let you do. Okay, I have taken a fairly large triangle and I've drawn two mid-segments, sketched very roughly, which is okay. Two mid-segments, and I'm going to use the information that I've been given to find all of these missing measurements. What's the property of mid-segments and of triangles that will enable me to find this? So let's walk through it one at a time. So first I want to know what MN is. So, and MO. So I notice this RP is the mid-segment, and this is the third side away from that mid-segment. Remember that the mid-segment is half the length of this third side that it doesn't touch. So if the RP is 7.5 feet, how long is RO? It's got to be twice as long, right? Because this is half. So MO, I think I said RO, I meant MO. MO would be 15 feet. Remember, this N is a mid-segment. Therefore, I'm cutting that side in half. So MN would be 7.5 feet. So notice this mid-segment here is the same length as these two halves. They have the same relationship. Okay, let's find RN. So RN is the mid-segment associated with this third side, and we are given that QO is 22 feet long. So RN would have to be half of 22 feet. RN would be 11 feet. QM would be what, and how would we find it? Let me show you what you would do. If I label this triangle as I've been working, so if this is 7.5 and 7.5, right? The whole thing is 15. This is 11 and this is 90 degrees. Do I have a right triangle? So to find RM, you would use the Pythagorean theorem. RM squared plus 7.5 squared would equal 11 squared. And so by doing that with my calculator, I got that RM is about 8.0467. 8.0467, which is kind of big. I want QM, so I'm just going to double that. Because remember, this is the midpoint. So I just multiply this times 2 to see where the rounding should be, and I get about 16.1 for QM. So this is about 16.1, and this is about 8.0. That's the method that you would use in this case. And now I need to find in the measure of angle Q. Notice this is a large triangle. I already have these two angles. This is a right triangle. If this is 47, these two are complementary. Angle Q would have to be 43, because these two angles would have to add up to be 90. The last one is tricky. Can you see what it is? Angle RNO is here. How would we find that? I want you to remember that mid-segments are parallel with the third side. That means RN is parallel to QO. So these two are corresponding angles. If this is 47, this is also 47. And that angle forms a linear pair with 47. So those two angles would have to add up to 180. So go 180 minus that 47 and you get 133 degrees. And that is the last angle in this problem. So looking at relationships, it's like solving puzzles. It just gets so fun. That is what you do in a problem like this. So in this section, we've put triangles into a coordinate plane and looked at slope and distance formula to find lengths of sides. We found all about mid-segments, how to create them and their special magical qualities, their properties, how they are parallel to the third side and half of the length of the third side, and then being able to solve intricate diagrams, and even applying slope and distance formula with all variables, with no numbers at all, and showing how you can still see those relationships work. So that is the end of chapter 4. I will see you guys next in chapter 5.